Welcome to Lesson 6.7, Measuring Volume by Displacement. In Lesson 6.7, we are going to be able to use displacement to measure the volume of objects, and we're also going to be able to understand concepts of volume and relate volume to multiplication and addition. Let's warm up first. What is a common denominator between these factors? So let's take them one at a time. If we take a look, that didn't work for me. There we go. 1/3 minus 1/6. So we've got the denominator of 3 and 6. Then for the second one, we've got 5/8 plus 1/3. So the denominators of 8 and 3. And then we have 11/12 minus 2/3. So denominators of 12 and 3. Notice again on these, you are not being asked to solve them. You are simply being asked, what is the common denominator? So take a minute. Figure out what denominator would be common for all three of these problems and come back and let's talk about them. So for the first one, again, we said we had 3 and 6. We know that if we list the multiples of 3, we can get to 6, and 6 is already there, so 6 would be the common denominator. 8 and 3, we know that these are very different numbers. 3 is odd and 8 is even. 3 cannot become 8 easily. So we might want to do a QCD for this one and do 8 times 3, which would give us a common denominator of 24. And then finally, we have 12 and 3. I know that 3 can become 12 by taking 3 times 4, which equals 12. So I wouldn't need to change this one. So 12 would be my common denominator for the last set of problems. Hopefully you found those same denominators. For the first one, you may have done 3 times 6 and found the answer of 18, but 6 would be our least common, our easiest one that we would want to find. A review is the word displacement method, or the words displacement method. This is a method for measuring the volume of an object that involves submerging or placing something underwater and measuring how much the water moves. So we're going to be talking about finding volume using the displacement method. So you might find that you have seen objects like this before, an orange or a stick of butter. And we can find the volume of these because remember, volume is how much space they're taking up. So what do you think? How would you find the volume of either one of these objects? And would they be similar ways or would they be different ways? So since the orange is round, I hope you realize it's probably pretty difficult to draw a model using rectangular prisms that would give an accurate volume. Remember in the past lessons, like when we did guitar cases or trumpet cases, we used rectangular prisms to get an estimate of the volume. However, with an object like an orange, the rectangular prism is not going to be, as we see here, the word accurate. So we're going to learn a new method for measuring the volume of objects. And again, it's called the displacement method. So we're going to measure the volume of objects. And actually, since you're virtual, you are going to be given an opportunity to do this at home if you have the correct supplies. I do have a video that we can watch that'll show us what displacement method is for volume. And so we're just going to talk through all of this today. What you want to note here is that common units for measuring the unit or the volume of liquid includes liters, milliliters, gallons, and quarts. Think about going to the grocery store. If you're picking up some milk, we don't say that I'm going to pick up so many cubic centimeters of milk or so many cubic inches. We say I'm going to pick up a gallon or a half gallon, maybe a quart of ice cream, maybe a 2 liter of pop soda, whatever you call it. So we're going to be looking at milliliters today when we talk through this. To calibrate something, and that's going to be a word that you would come in contact with when you're talking about measuring volume by displacement, is to mark it with a scale. So, for example, the measuring cup has been calibrated to measure liquids in milliliters. So, if you turn to page 214 in your math journal, I'm just going to talk through this activity that you could do at home if you have the correct materials. And again, we understand that you might not have these at home, so we're just going to talk about this activity. So here it says the materials that you would want to do this experiment, connecting with measurement of volume by displacement. You want a 2-liter bottle with the top cut off. So you would need an adult to assist you with this activity. A bucket or a bowl with about 2 liters of water, measuring cup marked in milliliters, a ruler, scissors, paper, and tape. Again, if you're able to do this activity at home, please do this with an adult. If you can't do it, completely understanding. So we're going to fill the bottle with about 5 inches of water. That's a little bit more than halfway. Number 2, you would cut 1 inch by 6 inch strip of paper and tape that strip to the outside of the bottle with one end at the top of the bottle. The other end should be below the water level. You would mark the paper strip at the water level, write 0 milliliters or little m capital L for milliliters next to that mark. Number 4, you would use the measuring cup to pour exactly 100 milliliters of water into the bottle. You mark the paper strip at the new water level, write 100 milliliters next to that mark. Right here, you see an image that connects to that. Step 5 would be to pour another 100 milliliters of water into the bottle and mark the new water level and label that mark with 200 milliliters because now you have put 100 plus another 100. You would continue adding the 100 milliliters of water at a time until the water is less than 1 inch from the top of the bottle and mark and label each new water level. Pour water out of the bottle until the water level is back to 100 milliliters. So you'll see here what they did in this image. I believe I can zoom in for you. Right there. So you can see how they've marked all the different 100 milliliters. Right here represents 0 though. So in order to continue with this activity, you would want to talk about the calibration. The calibrated bottle you've created is a tool for measuring volume. So you want to ask yourself, how do you think that this tool could be used to find the volume of the orange? What would you do? What would happen if you put the orange in the bottle? Think about how could this bottle be used as a tool? If you drop the orange into this water, what would happen to the water level? So here I'm going to pause. I'm going to go over to this YouTube video since we can't actually do the activity, and we're going to watch this together.
Volume is the measure of the amount of space an object takes up. In a fish tank, we can find out what takes up more space, the rack or the filter. We need to measure the volume of both objects. To find the volume of the filter, we use the formula. Volume equals length times width times height. Using a ruler, we take measurements. The measured value for length is 5 centimeters. The width is 5 centimeters, and the height is 5 centimeters. Our calculated volume is 125 cubic centimeters. The shape of a rock is described as an irregular solid because it is not made up of simple shapes. As a result, we need to find the volume of the rock in a different way. To find the volume of an irregular solid, fill up a beaker with a known amount of water. Then drop the rock in. notice that the water level is higher. The movement of water is known as displacement. The amount that the water moved is 25 milliliters and is also the volume of the rock. Everything that takes up space in the fish tank has a measurable volume. If you were to enter the tank, think about how much water would be displaced. That's your volume.
Okay. So hopefully that gives you a little bit better idea about displacement and how it works. So again, you can use your calibrated bottles if you happen to make those with an adult at home to complete problems 1 through 4. And you'll see here, it's just a little experiment for you to do. Use the displacement method to find the volume in milliliters of base 10 flats if you had those. So I'm going to skip on actually because here we could see you could find that if you put in one base 10 flat, you would see that it's 100 milliliters. But if you actually measured it, you know that it's 100 centimeters cubed and so on. So if you put 2, that's 200 and 200. The volume should come out to be the same. So number 5 is where you could measure things on your own. You could find objects that would fit that maybe you could measure and also calculate by displacement. So now we know 2 strategies for measuring volume of objects. We can use mathematical models that are made up of prisms, or if possible, you can use the displacement method. Think about what are the advantages and disadvantages of each strategy. What would be the advantage of using the mathematical model that's made up of prisms, much like we did in the past with the trumpet cases or the guitar cases? We used a lot of instrument cases, if you remember. There's also, then what are the benefits of displacement method? When would you maybe use one over the other? Those are questions that you want to ask yourself. Then what you will have as an assignment you will find is that you are going to, in your own words, respond to this exit slip. You're going to describe how to use a calibrated bottle to measure volume by displacement. I'm going to ask you to put that into your own words. So remember, you can look back through this video. You can look at that YouTube video that we watched together. And that is the end of lesson 6-7. Again, that was about measuring volume by displacement. There's not a lot for you to do in the book, but I hope that you view this video and do the other activities that are connected so that you get a better understanding of using displacement to measure the volume of objects and understanding the concepts of volume and relate that volume to multiplication and addition.